Welcome to Huawei's Digital Power Club Global Tour Europe. Thank you for joining us today. My name is Saida Alam and I am the Marketing Manager Digital Power in Germany. Due to the high-speed development of industries, including 5G, big data centers, AI, industrial internet, UHV and EV chargers, the transformation of society to a digital economy is accelerating. Energy as the infrastructure of the digital world is facing huge challenges. Combining digital technology and power electronic technology, the Huawei Digital Power product line is driving watts by bits. It's leading the digitalization of energy, realizing green power generation and high-efficiency power consumption to build a smart and sustainable world. Today, we would like to invite you to discuss the challenges and opportunities of a digital power world. Meet our industry experts and listen to their thoughts and insights and real-life scenarios. Enjoy! Welcome to the Data Center and Site Power session. Let me first of all introduce Dr. Yangzhou Fang, a Vice President and CMO of the Digital Power product line. In his keynote speech today, he will talk on leading power digitalization for a smart and sustainable world. Welcome on stage, Dr. Fang.
Hello, ladies and gentlemen. My name is Fang Liangzhou, Vice President of Digital Power product line. It is my pleasure to deliver a speech on behalf of Digital Power product line. The topic today is that leading power digitalization for a smart and sustainable world. The main content today includes three parts. What's the scope of the Digital Power product line? Why we can bring more value to our customer through innovative technology? What's the idea and the key value to our customer? European Union declares new objective. Europe will be the first climate neutral continent by the 2050. There are three key steps to reach the target. Firstly, improving energy efficiency and increasing the proportion of the renewable energy. The target is reducing greenhouse gas emission from the transportation, such as increasing the proportion of the electric vehicle. Electric vehicle will be the 40 million by 2030, and charging pills will be 3 million by the 2030. Recently, European region became the largest electric vehicle market than China. Thirdly, using the digital technology such as AI, 5G, cloud, and IoT to improve social work efficiency. Then reducing the greenhouse gas emission. This is a good way to reduce the greenhouse gas emission. Meanwhile, there are also the big power consumption from the digital technology. If there is no control for power consumption from the ICT technology, the power consumption also is increased much more. Huawei is a leading ICT supplier. There are three types of product and solution in Huawei, which is device, connectivity, and computing solution. Although digital technology makes our world better than before, meanwhile, it's also bringing a huge power consumption. According to the third-party report, power consumption from the digital technology, such as telecom site and the data center, shares 3 or 4% total power consumption in the world. So, how to reduce the power consumption is a big challenge for our customer, also to the society. Digital power is a strong power foundation of the digital world. It focuses on energy processing, storage, and conversion with high efficiency. It can help customers reduce the power consumption. Huawei Digital Power product line scope includes two types of scenarios. Firstly, green energy generation. It is a smart PV solution. We provide a solar inverter, intelligent battery, and management system which can yield more green energy. Secondly, high efficiency to use energy, such as data center facility solution. We provide the power system, cooling system, and the DC management system for the data center, include the big data center and edge data center scenario. Site power facility solution. We provide the rectifier, intelligent lithium battery, and management system for different telecom scenarios, like access site, aggregation room, and central office, and so on. So for M-Power solution, we provide the power system, charging system, and a battery management system for electric vehicle. Modular power, we provide the rectifier module, UPS module, server power module, etc. for different industry. What's the difference between Huawei digital power solution with a traditional power and electronic supplier? We insist continuous innovation on power and electronics industry. Each year, we input 10% of our revenue to R&D department. We have the three kind of key technology to keep us a leading position, which is power electronic technology, telecommunication technology, and AI technology. We introduce the digital technology to traditional power electronics, which can create more value for our customer. Huawei is very strong on the digital technology. Digital power product line take advantage of digital technology. Our advanced power electronics technology can bring high efficiency, high density, and higher reliability for our customer through efficient component, leading topology, and advanced algorithm. For example, high efficiency. Our UPS module efficiency can reach 97.5%. If efficiency is 1% higher than UPS, it means the cost for saving electricity is equal to the cost for the UPS during 10 years lifespan. And also, our solar inverter efficiency is 99%. It's almost the highest efficiency in the world. High density. Our 5G power density is the highest. Traditional 24 kilowatt rectifier is 7 U-head. Our solution is only 3 U-head. And our 1 megawatt UPS is only 1 cabinet. And the traditional UPS need 2 or 3 cabinet. It can save more footprint. Higher reliability. Our solar inverter can access grid even under low SCR situation. Traditional power solution is very difficult on management because it is difficult for digitalization of power electronics equipment and information transmission. We use different transmission technology for short distance and long distance scenario, which make it easy to transmit data between power equipment and management equipment. For example, we use Zigbee technology to communicate between the battery and power system. We use PLC technology to communicate between the solar inverter and transformer station. We use the IoT technology for the lithium battery. This telecommunication technology are easy to install and also reduce time to the market. AI technology can solve many complicated problems, which is very difficult for the traditional technology to solve. Huawei has a strong AI platform, which already used in different product and solution in Huawei. So we can introduce AI technology to our power and electronic solution to solve some big problem. For example, our smart IV curve, based on the AI technology, can detect 100 megawatt solar plant in 15 minutes. It will take 10 days with 10 people for 10 random inspection for 100 megawatt solar plant if we choose the traditional way. We use eye cooling also based on the AI technology for the data center, which can reduce PUE 8 to 15%. It can save electricity a lot. We also use cloud BMS to manage lithium battery, which can improve reliability and capability for the battery. For solar solution, our idea is generating more watt from every PV plant. We lead traditional solar solution to fully digital solar PV plant, which can yield more power and improve O&M efficiency. We change the solar inverter solution from the central inverter to the string inverter. Now almost 62% inverter are string inverter. We also push solar energy from the supplementary energy to the major energy because of lower cost of electricity. For data center solution, our idea is enable more computing power per watt. We make data center simpler than traditional way through the leading architecture innovation. For example, modular power supply, modular cooling system, modular data center, which shorten data center time to the market, and also build a data center on demand, smooth evolution to the future. We also introduce AI tech into the data center facility, which make data center more intelligent. For example, eye cooling technology can reduce the PUE 8% to 15%. Eye power can improve reliability through the predictive maintenance. For site power facility solution, our idea is enables more bits on each watt. We lead transformation from the telecom site to the intelligent site, which makes site solutions simple, high efficiency, and intelligent. We lead the change from the telecom site to the social site, which can provide the power not only for the telecom equipment, but also for family, community, etc., which help our customer to get more revenue and improve profit from the site. For M-Power solution, our idea is a longer cruising range per watt. We push NEV into the digital area with cloud network chips, which make NEV more safe and efficient. Our innovative next generation power platform make electrical vehicle simple, safe, good experience, and intelligence. Huawei Power Solution already serve millions of pieces worldwide. In the past, we only use our modular power for Huawei ICT solution. We don't sell it to the third party. Now our new strategy is Huawei Power Inside. Our partner or customer which need our advanced modular power can cooperate with us. The product includes AC-DC power, DC-DC power, and CT power, IT power, and so on. We also like to cooperate with our partner to create a new area. Our software platform is open. We welcome our partner to develop application based on our software platform. Our hardware modular power support to be integrated. We also welcome ecosystem partner to work together with us and win to win in the future. Our mission is leading power digitalization for a smart and sustainable world. Thank you.
I'm happy to introduce Mr. Sanjay Kumar Sainani, General VP and CTO of the data center product line at Huawei. Today he will talk on top 10 emerging trends of the data center facilities for 2025. Welcome on stage, Sanjay.
Hello everyone. Welcome to our webinar series. My name is Sanjay Sainani. I'm the SVP and CTO at Huawei Technologies. Now, the data center industry has witnessed a spectacular decade. Data centers have evolved from being ICT equipment rooms to finally cloud data centers. This is clearly due to the development of emerging technologies, including cloud computing, big data, IoT. And as more adoption of AI and 5G happens, the next decade looks extremely promising. There will be challenges too. As more businesses move towards offering their services through the digital networks, the market demand for data centers will increase dramatically. And these data centers clearly will face challenges in terms of obtaining resources, construction cycles, high energy consumption, not to mention the flexibility and the cost. We definitely will have to address these challenges to meet the development requirements of the cloud computing age. We often overestimate the changes that will happen in the next 1 to 2 years, but underestimate the changes that will occur in the next 5 to 10 years. I would like to share with you some development trends of the data centers in the next 5 years. Here are the top emerging trends in the data center facility space. The industrial trends: high density, scalability, green and sustainable, short time to market, fast, and high availability. On the technical side, going modular, simplifying the architecture, converged liquid and air cooling. A new trend, bit manages what? And clearly leveraging AI enablement in the data center facility. One of the first trends we see is high density. Clearly, the ability of the chipset is increasing exponentially. A 2-socket server today can easily consume 600 to 800 watts. With more and more penetration of the CPU and GPU in the AI space, we are looking at these densities to increase even further. Huawei's AI chip, the SN910 today, is able to deliver about 256 teraflops, consumes a little bit over 300 watts per chip. We can package in a 4U chassis almost 2 petaflops, giving us somewhere around 6.5 kilowatt per chassis. You can add 10 of them in a rack, leading to almost 60 kilowatt per rack. So clearly, the new data centers will have to have the capability to handle these high density loads. Trend 2, flexible and scalable through IT evolution cycles. The IT device life cycle is 3 to 5 years. The data center life cycle is from 10 to 15 years, which means the data center facility has to handle at least 3 evolutionary cycles of the IT infrastructure. On top of this, the density doubling every 3 to 5 years. So clearly, the data center facility will see over its life cycle a coexistence of various generations of IT infrastructure and various densities, requiring the data centers to be more future-proof to handle this IT evolution. Trend 3, a focus on social responsibility. The carbon footprint goes through an entire life cycle of a data center. In China alone, if you look at the 2018 carbon emissions from data centers, you would require about 500,000 hectares worth of forest to absorb these emissions. Clearly, use of clean energy, recovering waste heat, finding smart ways for carbon capture becomes very important. Data centers going into tens of megawatts and data center districts going into hundreds of megawatts. Data centers today represent anywhere between 3 to 4% of global energy consumption. If you add on top of this the compounded growth rate that we are expecting, data centers will become a larger footprint in terms of energy consumption. Clearly, the goal will be to reduce the energy consumption. And finally, with the explosive demand for data centers, consumption of resources, whether it's land, energy, water, materials, is going to be extremely important. Finding smarter ways for lean construction, renewable resources, selecting green and friendly materials will become very important. Trend 4, fast deployment. There's been a tremendous increase in service requirements resulting in an extreme fast data center deployment need. If you look at the time it has taken for different applications to acquire about 500 million active users, it took Instagram about 6 years to get about 500 million users, and it has taken TikTok only 3 years to reach the same level. They have actually added 188 million users in a single quarter. Gives you an idea of the explosive growth in terms of digital services and therefore capability to deliver it through the digital infrastructure. The data center has transformed from being a support system to a production system. Service provisioning now has moved from months and weeks to hours. Tenants require on-demand supply. Investment has to be on-demand and very scalable to reduce the capital costs. Investors are demanding faster returns. The time to market today to deploy a new data center facility is anywhere between 9 to 12 months, and this will continue to reduce in the future. Fast deployment is one of the most important trends going forward. Trend 5, trust assurance. The cybersecurity situation has been worsening. The number of IoT attacks, vulnerabilities on industrial control, global mining viruses, ransomware, everything has increased in the last few years. Clearly, the governments have realized the importance of infrastructure cybersecurity and are drawing up new cybersecurity legislations. Trustworthiness will be key in the data center space going forward. Resilience, security, privacy, safety, reliability, and availability will be a key trend in the data center space. Let's now look at some of the technology trends that will help us to meet the expectations of the business. Trend 6 is modularity. We have evolved from modular components to modular architecture over the last many years, where we now see a trend of completely modular buildings. In fact, prefabricated data centers where even the building is modular in nature. What this is doing is it is helping the customers to put together a much lean construction model on site, get far more predictable response, and more importantly, reduce the time to market by almost 50%. This trend is helping both in terms of return on capital employed and return on investment. Trend 7, simplified architecture. As data centers become larger in size, the demand for availability keeps increasing. The need to simplify the architecture, especially to enhance the availability and reduce the footprint, is becoming very important. We see a trend of pre-integrating the complete powertrain from transformer, distribution, UPSs, batteries, all the way down to the server rack to help allow a new generation of modular power architecture, which allows us to reduce the cost, improve the efficiency, and more importantly, reduce the time to deploy it on site. The same thing is also being found on the battery infrastructure. Clearly, batteries over the last many decades have occupied both a lot of cost and footprint. With the new lithium-ion batteries, we see a tremendous reduction in the footprint and weight, thereby allowing this saving of footprint to move towards the white space. A simplified architecture that is being delivered through a pre-integrated modular approach. Trend 8, converged cooling. The energy consumption for cooling within a data center is the single largest contributor towards the increased PUE. For medium and large data centers, we typically use a chilled water cooling system. This has between 7 to 8 key components, from cooling towers and chillers on the outside to air handlers on the inside, and about 3 to 4 heat exchange stages. There clearly is an entitlement here to reduce the complexity of the cooling system as well as improve the efficiency. There's a growing trend to use indirect evaporative cooling, wherein a whole cooling system can be integrated on a single skid. thereby reducing the complexity of installation, operations, and maintenance. And also the number of heat exchange stages are reduced by almost half, thereby providing tremendous gains in PV. Further enhancements on material technology have improved the heat exchange efficiency as well as reduced wind resistance. As the density keeps increasing within the data center space, we see an uncertainty in terms of the service requirements for the future. There's a growing trend to converge both liquid cooling and air cooling within the data center space. An alignment of the liquid and air cooling could be done then using controlled and unified algorithms, thereby providing far better elastic dissipation of heat within the data center space. Trend 9, bit manages watt. Now we know that PUE is an internationally accepted performance indicator for energy efficiency within the data center space. However, reducing PUE does not necessarily mean that overall data center energy consumption is optimal. We need to look at energy consumption of the data center as a whole. There's a growing trend to look at energy consumption per unit of computing power. We have seen through actual deployments that linking the facility layer to the infrastructure layer reduces energy consumption per unit of computing power by almost 15%. Further linking this with the service platform layer, where you can bring in better and smarter prediction and migration technologies and hibernation modes, provides further reduction of energy consumption by 5%. This is a growing trend to move towards bit managing the watts. Trend 10, AI-enabled autonomous operation. As we accelerate in our journey towards a digital economy and roll out more digital services, the data center facilities are evolving from a few megawatt to hundreds of megawatts. Furthermore, we expect an increase of thousands of edge data centers as new services come online. The data center facility O&M will be challenged by the sheer scale of the size and the spread, making manual O&M more challenging and costly than ever. The situation will further get exacerbated as O&M talent shortage will continue to grow and the persisting business pressure for higher availability. We see a growing trend for AI-enabled autonomous operation. Millions of data points across data center facility infra being analyzed for trends and insights. Machine-trained platforms to look for visual and audible anomalies. Ability to conduct remote unassisted inspections. Best practice and insight-driven predictive maintenance replacing preventive maintenance. AI-enabled energy-optimized operation of power and cooling systems. A future of autonomous operation of data center facilities leveraging AI. Thank you for spending your time with me today. We at Huawei are invested deeply and working alongside industry partners in bringing new innovative solutions in the data center facility space. Thank you. Have a great day.
Thanks, Sanjay. Now I'm happy to introduce Mr. Michel Fraisse. Michel is our VP of the Telecom Power and CTO of Digital Power product line. Today he's going to talk about building future smart data center. Michel, the stage is yours.
Good afternoon, ladies and gentlemen. I am Michel Fraisse. I'm Europe CTO and Vice President for Huawei Digital Power. Today I will take you through a journey on how to build the smart data centers. First of all, I would like to mention the 4 challenges that you will face if you build a data centers in a traditional way. The first one will be a long construction period. It will take you times to do the civil work, to get all the equipment on site, to verify that everything is working well together. Second one is quite an inflexible way of doing things. You need to plan everything in advance. You need to invest in everything in advance, even if you have very few customers to start with. So cash might be an issue. then it can be low efficiency. Assembling different products together, different equipment together, may take you to a PUE of up to 2, which is quite high compared to what we can do today. In Europe, in London, for example, we got a new data centers built for one of our customers with a PUE of 1.2. And then the management of the data centers is also very important. One of the key issues today is to find good manpower. According to Uptime, 61% is a lack of good qualified personnel to manage the data centers. So on-site maintenance is required. It's difficult to find the causes for some failures. So this is the 4 key points that we like to target today. So our idea in Huawei is to reshape the data centers to be a smart data centers. So how do we plan to do that? First one is reshape the power supply. We want to give you ultimate reliability and very high efficiency solutions. The second point is reshape the cooling. Again, cooling is one big part of the operation costs and electricity bill. So you need to make sure that the cooling is sufficient, but not too big, because then the electricity bill will become too big. The third one will be reshape the OEM, the operation and maintenance, to make it more efficient. And finally, you need to look at a complete architecture, and you need to reshape the architecture. Reshaping the architecture for outdoor scenarios, for large data centers or for edge data centers, or for indoor scenarios, again, for large data centers or for edge data centers. So let's go through these 4 key points. Reshaping the architecture. We're going to do it by using fully modular and prefabricated modules. The idea is instead of building a data centers in 2 years, you can do it in 6 to 9 months. So the idea, you're going to have a power modules, you're going to have some cooling modules, you're going to have some IT modules, you're going to assemble everything together, and then you can have a complete building, as this is shown in these videos that you can see. The video you're seeing here is Huawei Cloud prefabricated data centers in Dongguan. There is 1,000 IT rack, up to 8 megawatt of IT loads, and this building has been built in less than 9 months. Now we are building the third one. So this is something that Huawei had been experiencing in its own data centers before duplicating this with our customers. Reshaping the architecture. So we got solution for indoor edge data centers. So this is small all-in-one prefabricated data centers for L1 and L2 layers. Everything is pre-engineered, everything is pre-installed, pre-tested, and then it's delivered on site, so it's been quick to deploy and quick to operate. The second one is outdoor edge data centers. So similar to the indoor one, this is prefab outdoor modules where you can have up to, for example, 6 IT rack with 10 kilowatt of IT power inside, for example. Or we can also have an outdoor solutions. So this is a big outdoor cabinet, which is cooled by air conditioning N+1, which is powered by a very reliable eMIMO platform from Huawei with some lithium batteries, where you can put both IT and telecom equipment, for example. One point is also to have a centralized management systems, so a DCIM, which is intelligence. So you can have all the information from one centralized locations. You can have the same information using one pad or your iPad or your iPhone or your Huawei pad or your Huawei phone. So everything is becoming simple. Okay, so we saw how Huawei planned to reshape the architecture. Now let's see how Huawei planned to reshape the power. If we look back in the times, early UPS were transformer-based UPS together with lead acid, was big and bulky and low efficiency. Then we moved to high frequency tower UPS, still with lead acids, with new components, making the efficiency better. Then we went to modular UPS, and Huawei has been keen in developing these technologies and improving these technologies over the years, together with lithium ions. Efficiency moved up to 96%. At the time, we got 100 kVA in 6U, the first generations. A bit more than a year ago, we introduced this new 100 kilowatts in 3U modules, UPS. Now we are talking about efficiency of 97%. We're talking about very high power density. And we're talking about associating this UPS with Smartly, which is our latest generation of lithium-ion batteries. And then we went one step further. We integrated the transformer, we integrated the AC input distribution, the AC output distributions, the UPS and the batteries in one complete modules, one power pod, as we call it. So how do we plan to reshape the power? Fusion power, UPS, and Smartly batteries, lithium-ion batteries. This is our secret weapon, I would say. The idea is to save space up to 60%, to make things simple, and to lower your total cost of ownership. In this example, we're talking about a 1.6 megawatt UPS. And this 1.6 megawatt UPS, traditional ways, can be built using 3 times 800 kilowatts UPS with each batteries, lead-acid batteries connected to the UPS. Or we can use a 1.6 megawatt fusion power UPS using the 100 kilowatts, very high efficiency, 97% modules, together with some, Smartly lithium-ion UPS batteries. In that case, we're going to go from almost 26 square meters to 10 square meters. All this space that you are saving, this is space you can use to put IT racks. This space you can use to make money. So we plan to reshape the power as well with our power pod solutions, which is a full chain convergent power systems. Instead of having multiple vendors, instead of having manual inspections, instead of having low power efficiency, the idea is to have very simple solutions, reducing the time to market by 75%, reducing the footprint by 30%, increasing the system efficiency hand-to-hand to 95.5% or above, to add intelligence, so you can know what's going on in your system, you can visualize everything, and so it can be easy to manage. And you need to be, of course, reliable, because what we're saying is peace of mind. So the idea is, that in advance what may happen to your power system. So we added intelligence into the system. We added AI, so you can predict, the maintenance of your power systems. You can plan this maintenance, so you can reduce your, operation and maintenance cost. These solutions are available on both indoor and outdoor scenarios. We talk about architecture, we talk about power. Now let's have a word about cooling. Cooling is one big part of the spending of the electricity bill. So we need to have enough cooling, but we don't want to have too much cooling because it costs a lot of money. Electricity is money, but it's also carbon emissions, so it's not good for the environment. So the idea is to have very low PUE. And working on cooling is very key. So the idea is to cool the devices as close as possible. So for example, you can have liquid cooling on board level. You can have in-row cooling close to the IT racks. You can have also in-room cooling. So we need to have all these systems the most efficient as possible. So we need to simplify the architecture. We need to use natural cooling as much as possible when it's possible to reduce the power consumptions and to become greener. So let's talk about indirect evaporative cooling, which is for Huawei the ultimate energy saving solutions with very simple delivery. Instead of having today multiple vendors, multiple equipment to be assembled on site to give you cooling solutions, we decided to put everything in one module. So Huawei is going to supply you one pre-engineered, prefabricated cooling solution. It's all in one. The advantage is you can have a PUE of less 1.2 in London, for example. You can install this system in less than 15 days, 2 weeks. And you can have also AI-based intelligent inspections, so you can have efficient operation and maintenance. We can also improve the energy saving, or we can decrease the electricity consumption by 8 to 15%. This is because we can have artificial intelligence running the power, running the cooling, so that the cooling, for example, will be automatically adjusted according to the needs for the IT equipment in the different racks. DCIM, which is called NetEco 6000, received the Red Dot Award in 2020. So this is, we are very proud of this. Big recognition from the market for the simplicity of our solutions. We also need to mention that we are compliant to the ITU standards. So now let's look at a few real cases that I want to share with you. The first one is how to build data centers in a French castle. So this castle is in the Loire area, close to the city of Angers in France. The challenge was to be able to squeeze data centers in some rooms which were, quite narrow. The second challenge with traditional solutions was that you needed two rooms, one for the power room, one for the battery room. So this is the challenge. Our answer was to deploy a smart modular data centers using our, very compact high power density, UPS systems and smartly lithium ion inside. So you got everything in one room. The second case is the power pod we supplied in Dongguan for our own Huawei data centers. So as mentioned at the beginning of these presentations, if you remember, it's a 1,000 IT rack, it's 8 megawatt of IT loads. And so basically we install this outdoor power pod because it was simple, it was green, and it is a reliable solution. This data center, by the way, can be visited. I know this is not the right time to travel, but when we be able to travel, this is something you can see. We help Vianet, 21 Vianet, to build an innovative data center. We sold them 28 sets of modular UPS 5000s and 40 sets of Smartly. One key thing about Smartly I need to say now is that if you lose one of the battery block inside, it will keep on running. If you had a battery made of lead acid battery block, if you lose one battery block inside your solutions, you will lose the complete battery string. So this is, fault tolerant. This is, also buying reliability and peace of mind again. Finally, I would like to share with you one last case. This is from one of our customers in China, Global Data Solutions, where we build a new benchmark in terms of data center energy savings. By implementing our indirect evaporative cooling solutions, all-in-one, Fusion Core 8000-E, as we call it by the name, we reduce the time to market from 16 to 8 months. We reduce the PUE from 1.4 to 1.2, which is reducing the electricity bill by 14.3%. But not only we reduce the electricity bill, we also reduce the water usage, which is also important, by 40%. So this was the last slide of these presentations. I hope that after attending these sessions, if you have any data center project, being small, medium, or big, being indoor, being outdoor, being large data centers or edge data centers, you will see that Huawei got a solution for you. With Huawei, you will have state-of-the-art, high efficiency, high power density components. We will have an architecture will allow you to reduce your electricity bill, to reduce your CO2 emission and become greener, and to save the planet. Thank you very much. Hope you have a good day.
Thanks, Michel, for the very insightful presentation today. Now I'd like to invite our colleague, Mr. Roland Hümpfner from Nuremberg, Germany on stage. Roland is the director of the Power Conversion Technology Lab, and he will talk about modular converged power architecture and data center.
Welcome from my side to our today's event. I would like to introduce you to the latest edition of data center power infrastructure. Fusion Power, leading the future of data center supply infrastructure. My name is Roland Hümpfner and I'm responsible for the Power Conversion Technology Lab in Nuremberg Research Center, Germany for Huawei Technologies. In this presentation, we'll go over the power supply trends, the advantages of Smart Li UPS, and the introduction of Fusion Power 6000, an integrated power supply chain, and finally, we'll summarize some market successes. Challenge 1. The power occupies more and more space in the data center. Due to the accelerated demand for more and more data processing performance, the power requirements and the power density of modern servers are increasing continuously. In the latest AI application, we find easily 310 watts in a Ascendant 910 or a power demand of 6.6 kilowatts per AI server set, such as an Atlas 800. In an AI cluster, 56 kilowatts per cabinet can be easily reached. The modern power infrastructure solutions needs to cope with this increasing power demand of IT loads. Let's look into the space requirements of the power infrastructure area needed in 3 different power requirements per rack. Starting from a power density of 4 kilowatts per rack, where the ratio of the required area for the power infrastructure in the IT space is 1:8, which basically means around 11% of the available area is occupied by the power and almost 90% can be utilized by the IT components. If the power demand per rack will increase to 8 kilowatts per rack based on the same density of the power infrastructure, the ratio is reduced to 1:4, which means already 20% of the total area will be dedicated to power and 80% is available for IT. Going one step further to 12 kilowatts per rack, the ratio gets down to only 1:2, which basically means 1/3 of the total space is occupied by power and only 2/3 can be used by white space. I understand this is a simplified consideration, but it shows the issue. How can we increase the power density of the supply infrastructure to keep a reasonable ratio between IT and infrastructure space? Challenge 2. Power supply and distribution failures are the main cause of business interruption. This slide shows an overview of outage root causes in the data center from a survey of Uptime Institute gathered for the year 2018 and 2019. According to this global survey, the on-premises data power failures represents 1/3 of all the power center outage reasons. It has been on the same level in the 2 investigated years. Together with the next category, network failures, also in both years on a similar level with around 30%, we can already cover almost 2/3 of the downtime issues. The other reasons are split into several groups led by IT software system errors, changing from 29% in 2018 to 19% in 2019. Despite of the fact modern data centers have a very high uptime, there is the demand to improve the on-premises power solution infrastructure. How can we increase this reliability? Hyperscale data centers are complex and require long installation time. As you can see from the picture, the hyperscale power infrastructure employs many components. We can see a dual feed architecture with 2 independent connections on the utility and a common diesel backup generator on the MV side. The MV PDU allows flexible source selections between the three sources. After the MV transformer, we can see the LV PDU, which again is prepared for flexible source selection, followed by two battery buffered UPS systems. On the output of the UPS, the power is routed independently to the dual feed ID loads. With this application, we can have a highly reliable power infrastructure, but we suffer long installation times, complex O&M, and require large footprints. How can we find better solutions to optimize the overall performance? Industry power supply trends. Looking into the history of UPSs, we can see a clear trend of efficiency increase and improved density, starting from the space-consuming SCR-based UPS with an efficiency of less than 90%, followed by continuous improvement in efficiency and power density. With the latest Smart Li UPS from Huawei, we can achieve 97% efficiency. Let's have a look to the Smart Li UPS from Huawei. The UPS 5000H is based on a 3U high 100 kilowatt UPS module. This power density is superior on the market. It doubles the power density compared with the Huawei UPS 5000S or E, which are based on 50 kilowatt modules. Now we fit in a 19-inch space 100 kilowatt. This represents the highest power density in the world of UPSs. Here you can see the front view of a 1.2 megawatt system. The first cabinet hosts 10 100 kilowatt UPS power modules. In the next cabinet you can find the remaining UPS modules, the static bypass and the control unit. The double conversion UPS with a frame size of 1200 kVA will allow fully hot swappable modules with an internal redundancy and an efficiency of up to 97%. It supports several lead-acid battery configurations in a wide cell range as well as Huawei Smart Li batteries. The high-density 100 kilowatt modules delivers full power performance also on an output unity power factor. The system has a centralized bypass. With an accessory kit, it supports operation without input neutral, or with another kit, it can be placed against the wall. Here we can see the top view arrangement of the accessory kit to put the UPS against the wall. In the standard layout, the unit needs a 500 mm distance on the rear side. With the addition of a 400 mm wide top outlet kit, the system redirects the hot air to the top side of the UPS. In front, a 950 mm service space is recommended. On this slide, we can see on the left side the no input neutral kit, which adds a 600 mm wide cabinet. On the right side, we see the bottom entry kit. This adds a 400 mm wide cabinet on both sides of the UPS. In the standard, all power connections of the 5000H 1200 kVA are located on the top of the cabinet. This arrangement supports an easy connection to busbar systems for the AC input and output connections. The battery terminal uses cable connections. Despite of the separate mains and bypass input terminals, the standard has an internal busbar link between the two sources, so a single input connection is sufficient. In case of two supplies, this link can be removed easily. On this slide, we see all the major components of the Huawei lithium-ion battery cabinet. The monitoring module, shown in number 1, is on the top left side of the cabinet and allows easy communication to the connected UPS. The battery breaker, shown in number 2, on the top right protects the battery and can be tripped by the controller unit. The two string fuses, shown as number 3, in the layer below, protects the individual strings. These fuses are prepared for easy maintenance. The intelligent battery management module takes care of a controlled charging and discharging of the two battery strings. The modules are arranged in 2 columns with 8 pieces of lithium-ion battery modules marked as number 6. The battery is based on lithium iron phosphate LFP technology. The monitoring unit, shown as number 5, provides a local HMI and allows the user to have an inside look to the status of the whole battery cabinet. The battery can be discharged with 6C, which means a 10 minutes discharge time. The charge current can be selected between 0.1C and 1C. It has an operating DC voltage between 400 volts and 544 volts and can handle 5,000 cycles at a DOD of 50%. This slide shows the overall dimension and the layout of a lithium-ion battery cabinet. It is 600 mm wide, 850 mm deep and 2000 mm high. In the front, 800 mm service space is required. On the top of the unit we need to reserve 500 mm. On the right and left and rear side, no minimum distance is necessary. Cabinet level fire extinguisher. Using lithium batteries is a concern to many users. Despite of our safe LFP technology and our comprehensive BMS, we added a cabinet level fire extinguishing system. It operates on a fire detection pipe and it is temperature triggered. It has an on-site filled gas cylinder which is pressure monitored to ensure always availability of the firefighting system. The system works independent from the room level fire extinguishing system and will not trigger it. How does the outstanding power density perform in terms of footprint? On this slide you can see the front view of 2 UPS systems with a total power of 1200 kVA. On the left side you see the combination of 2 600 kVA UPSs based on 50 kW modules operating in parallel with the corresponding input and output arrangements, in total 8 cabinets. On the right side you see the Huawei Fusion Power 1.2 MW containing the 3U 100 kW power module with in total 4 cabinets. This is a saving of 50%. On the next slide you see the top view arrangement of 2 solutions including battery space in a typical arrangement. The right side uses valve regulated lead acid batteries on racks. Together with the 2 × 600 kVA UPSs, a footprint of 52 square meters is required. The 1.2 MW Fusion Power is combined with a Huawei SmartLi battery. The footprint required is now only 25 square meters, which is a saving of 50%. The combination of the modular fusion power and the Huawei Smart Li batteries provides another key advantage. Let's assume the final power of the system would be required as 1200 kilowatts 10 minutes. In phase 1, a power of 600 kVA and 10 minutes should be deployed. This means initially at 1.2 megawatt cabinet with 6 power modules would be required, together with 3 battery cabinets including the lithium-ion batteries, and on top of it another 3 empty cabinets to prepare for the later expansion. In phase 2, several years later, 6 or more modules must be deployed and the 3 empty battery cabinets must be populated with lithium-ion battery modules. This approach will minimize the cost in phase 1 and allows a relatively simple expansion in phase 2, avoiding any downtime. Let's see the integration level of the Fusion Power 6000 and its advantages. What should a current large data center design include? Standardization, modularity, sustainability are not only key words, they must be incorporated in modern data center designs. Fast deployment, maintainability and PUE optimization are added to the challenges to be achieved. This will lead to scalable solutions where a data center can grow on demand, and with a standardized approach, also planning efforts can be reduced, as well as pre-manufactured subsystems will allow off-site manufacturing and test to accelerate the on-site construction phase. How can we achieve these targets? The convergent solution of a megawatt UPS with matching transformer capacity is our best choice. Fusion Power 6000 covers all the components circulated in red in an integrated solution. Starting from a 1.2 MVA to more than 3 MVA, we offer various ratings to suit different power partitioning strategies. This high level of integration offers a significant footprint saving of up to 50% depending on the considered rating. How does a full power chain integrated solution look like? On this slide you see the picture of an indoor 1.2 Fusion Power 6000 on the top, and on the bottom the outdoor version hosted in a container with a rating of 2.4 megawatts. Here you can see the application scenarios for outdoor prefabricated in a container and for indoor also prefabricated on a skid base or prefabricated parts in bulk shipments which are finally assembled on site. Prefabrication ensuring the installation and delivery quality, time to market reduction by 75%. What is the difference in the on-site installation and debugging time between a traditional approach and the Fusion 6000 solution? In a traditional way, many on-site connections are required and cabling needs to be prepared locally. In the pre-manufactured solution, the on-site work is reduced drastically. As a consequence, the installation and test time can be reduced from around 2 months in the standard solution to only 2 weeks for the pre-manufactured, which is a reduction in time by 75%. On this slide, you can see the space saving of an all-in-one column compared with a traditional solution. The size of the layout on the left and right size is exactly the same. While the traditional approach consists of 4 × 400 kVA and delivers 1.6 MVA IT power on the right side, we see the same space double the power in 2 columns with each 1.6 MVA. which basically provides a space saving of 50%. Visibility and controllability. Fault prediction supports availability and uptime of a power system. With the Fusion Power 6000, we implemented a central monitoring to guarantee full visibility of all system components. With this, we recognize abnormal and critical conditions in advance and manage the situation in the overall context. This brings us close to the end of my presentation. Let's have a final look to our successful cases. Here we show our market acceptance by numbers. As the global number one in shipments of modular power solutions with a share of 34.3%, according to Frost & Sullivan in 2019, we are definitely leading this segment. As modular concepts are more and more popular, therefore we rank in the Chinese market as number one suppliers for UPSs in general with more than 16%, and lead the Chinese modular market with almost 40% market share. Further, we brought in the recent 9 years more than 5,000 lithium-ion batteries into our application and obtained awards like Yearly Best Company in Modular UPSs. Thank you for your attention.
Thanks, Roland. So now let's invite Ms. Violaine Petit on stage. She is the Sales and Marketing VP at CRT Informatique. Today she will talk about her experience in her speech on partnering to power the digital data center. The stage is yours, Violaine.
So hi everybody, I'm Violaine Petit and I'm currently working at CRT company as a sales and marketing VP. And first of all, we would like to thank Huawei for inviting us at this event. Today we are going to talk about our project for which we have chosen Huawei as the supplier. So this nice picture may intrigue you. This picture represents what makes us different. So let me explain. This castle is located near the Loire Valley in Angers. It's 200 miles away from Paris and it's in the west of France. Le Château de la Romannerie was built in 1642 and it was for a long time the residence of French king's doctors. It has received many men who have marked the French history, such as Charles de Gaulle. Classified as an historical monument in 1972, until today it was a place of French gastronomy. So, what is the link with the data center? Why are we talking about an historical castle? So the east wing of the castle that you can see in the picture will host a data center, which is a new activity of CRT Informatique. It's going to support a high level of availability and a high level of service. It will be composed of 2 rooms. The first one will be a room to generic data, and the second room will be to medical data. In addition, this place will also become CRT offices. But what is the point of building a data center in a castle? So let me tell you. In any new project, CRT must put forward a new concept to differentiate itself in the competition. We did not want to build something in a concrete cube, something normal. We want to be different, and when we are different, we win in the market. We wanted also to put forward a new image of our company by the Association of Digital and French Heritage, by financing its restoration, to also invest in a meaningful project for customers, especially our public services customers, which was an important point for us. Also, we wanted to reuse the energy produced by the data center. So these are the main ideas the main thing why we choose this new concept. So, CRT is a human-sized company. We were created in 1990, so there is 30 years of existence. We have 2 agencies in France and 25 employees and 6 million revenue. But what are CRT activities? There we have different type of activities. The first one is the seamless installation and monitoring activity. We also have a more important activity, which is the Internet Service Provider activity and the network management activities. And now we are adding a new activity, data hosting. So, who should attend this data center? It will be a local data center whose targets will be public services like local authorities, education, research, school, universities. Also local businesses. The castle is local, so we want to work with customers of our area. And there is the data center is also for the medical sector, such as hospital, radiologists, laboratories, which are customers who need this kind of service. So now let's talk about our choice. Why Huawei? We chose Huawei because Huawei proposes a turnkey offer with the infrastructure DC, the networks, and the cloud computing. There is also the training and the maintenance services. Huawei services covers the full scope of our needs with a turnkey offer, which is the main point. So on which criteria was the selection made? We made our selection by order, and first it will be the turnkey offer. As I just said, it's important to have a solution where everything is included and cover the entire project scope. Also, of course, there is the best price-performance ratio, the guarantee of results and resources for Huawei, and the sense of partnership, the sense of listening, which are also important. And to finish, there is also the management of the constraints related to the building listed as an historic monument. The castle is an historic monument, so we can't do whatever we want with the data center inside the castle. Which services will we offer with this data center? So we are going to host data, of course, generic data and medical data. We also are going to provide the infrastructure as a service, the software as a service, and the service of the e-enterprise. But what is the e-enterprise? The e-enterprise provides a service in a minute thanks to the automation of reservation, of resources, concerning the provision of virtual desktop, virtual connection to a corporate network, internet access services, centralized storage spaces, etc., etc. All authenticated, secure, isolated, and maintained in operational conditions. So this is our vision of an e-enterprise. And what are the contributions of the e-enterprise? So for our corporate clients, it's going to be to optimize cost, pay as you grow, to refocus on their core business and the agility and the evolution of the company. We think this is the key to success. Yes. So if you want to know more, we will be pleased to welcome you at the castle. If you want to do a visit, the data center will be inaugurated in November 2020. And don't hesitate to come and visit with us.
Thank you very much, Violaine. Merci. Now we would like to talk about our new products. Please welcome on stage Mr. Yao Quan, Vice President of Side Power product line here at Huawei. Today he will talk about the new product launch iSide Power Solutions. Let's go, Mr. Yao.
Hi everyone, I'm Paul Yao from Huawei Side Power Facility Product Line. Welcome enjoying our iSide Power new solution release today. iSide Power is one of Huawei's strategic energy solutions. Our vision is to build an energy base for the digital world and accelerate industry digital transformation. This is Huawei's digital integrated side power facility solution. It is an integrated energy infrastructure solution tailored to the current emerging data transformation trend. And the overall design concepts can be summarized as a triple one, which is one integrated design, one platform, and one system. The one integrated design refers to the whole multi-functional all-in-one system. But this solution integrates power generation, power conversion, power distribution, power backup, energy storage, equipment housing, temperature control, and intelligent energy management. But we have also the feature of flexibility. Each functional component adopts modular design, including the power modules, lithium battery, PV panels, and even the cooling system. This allows the whole system can be flexibly combined to implement on-demand configurations. And more importantly, to support smooth evolution in the future. The second one platform, refers to the Huawei unique eMIMO power platform. eMIMO is a short for energy multi-input and multi-output. For the output part, the unified platform supports multi-standard voltage outputs, such as 12, 24, 48, 57 for DC power, and 220 for AC power. In other words, this one power system can meet the requirement of all the sensing, CT, IT devices. For the input part, the platform supports grid, solar, diesel generators. This enables flexible site deployment beyond grid conditions. And by adopting green energy, the solution can also help to reduce the dependence on diesel generator in poor man areas. In other words, this solution not only supports the deployment of digital sites in areas with stable grid supply, but also supports the universal power supply for social or livelihood power usage in unstable or even no grid areas. So now, we have simplified the deployment of process. But this is not enough. With the huge numbers of digital sites, we also need a convenient way for operation and maintenance works. This comes to our third one system. This refers to our remote intelligent management system, NetEco. NetEco implements remote visualization, management, and also controllable off-site devices, so that the maintenance staff can remotely monitor the site power status in real time and carry out some basic inspection works, like battery test, without the need of site visit. Therefore, operation and maintenance efficiency can be improved and huge maintenance cost can be saved. In addition, NetEco also supports multi-intelligent anti-theft functions, like remote video surveillance, e-lock management, PV and battery soft lock, and even the GPS tracking of stolen batteries, to improve site reliabilities and protect access. To sum up, through the 111 design concept, we are committed to this solution to achieve equipment construction-free, rapid deployment, flexible power supply, and intelligent management, so that to enable ubiquitous sensing, connecting, and computing. This solution can help our partners and customers solve power supply problems in two major scenarios: industrial digital sites and the universal power supply, especially in poor grid areas. Now, let me introduce them separately. First of all, as we mentioned at the beginning, the digitalization of all industries is accelerating. Business processing is shifting from manual operation to automatic operation. For example, in the electrical power industry, the monitoring of power distribution looms and power transmission lines are shifting from manual regular on-site inspection to automatic and intelligent real-time monitoring. In the field of eco-environmental protection, air monitoring, water quality monitoring, and transform from traditional manual sampling and monitoring to integrated site and automatic operations. This digital transformation of these industries is inseparable from the massive new construction of digital sites. Such changes are not far away. Some are just happening in our life. Take myself as an example. In the past, one of my most headache problems is the traffic jam, especially at the entrance and exits of highways, because the traditional toll collection method relies on manual working. Each vehicle needs to be stopped at the entrance of the highway to collect an MTC card, and later stop on the high-speed exit again, return the MTC card, and pay the fees. This leads to frequent traffic jam, often makes me later for my work. By the end of last October, 29 provinces in China has completed the cancellation of manual toll gates and replaced them with automatic control toll collection system. Now, cars no longer need to stop at high-speed entries or exits. Instead, they just go through gantry. The onboard unit in the car can interact with the ISU charging devices on the gantry to record the trip information and detect the highway fee. If the ISU fails to complete the fee detection due to faults or other reasons, the car information can be recorded by cameras for later charge. You can see there will also be flashing lights on the gantry to supplement light and ensure that cameras record accurate information. Of course, to accomplish the whole service process, you need more functional devices. Data, such as charging information, photos, and videos need to be sent back. So data exchange and transmission devices, such as switches, are required. For important checkpoints, IT devices such as storage servers are required to back up and process data in a timely manner. Now, all functional devices are available. We have found that it is an ICT convergent site that integrates sensoring, connecting, and computing. The next step is to meet the most fundamental requirement of power supply and build shelter facilities for those devices. However, we will find that the solution to this problem is not simple. On the one hand, the devices we mentioned requires different power input modules. For the cameras, it's 12 DC power or 24 AC power. For the ISU and the transmission devices, it's 48 DC power. And for the IT devices, the flashlight is 220 AC power. Traditional single standard power supply cannot meet all power supply requirements. However, if multiple power supplies are used, it is difficult to manage the power supplies. Moreover, it is not easy to house IT and CT devices, especially IT devices, which have strict requirements on the working environment. This is why, at the beginning of the project, the highway owners planned to build equipment rooms to house IT and CT devices, multiple sets of power supplies and batteries, and provide protection and temperature control. There is not enough space next to the highway, and the high cost and long period of construction are not affordable by the highway owners. This is why we have designed the digital integrated site power facility solution. We use the ultra-large capacity cabinets to provide reliable housing for old ICT devices, eliminating the needs for equipment room construction. The unified power supply platform can provide power modules for all devices at the site, eliminating the need for multiple sets of power supply. The power supply and batteries can be managed remotely and intelligently through the Unified Network Management System, NetEco, to reduce the unnecessary site visit and maintenance cost. Processing air conditioners and air clean box ensure data center level reliabilities. The M+1 backup design of core components, such as power generation, backup power, power supply, and temperature control, ensure zero interruption of tool connection services. In this way, only one cabinet is required, and the construction time is less than half a day. In addition to open load tooling scenarios, this solution can also be applied to smart campus, to implement edge computing data centers, and to 5G sharing sites for the electrical power industry. Enables operators to share 5G networks with the electrical city power industry. Water quality monitoring station, facilitating the transformation from on-site sampling monitor to automatic monitor. In summary, the digital integrated site power facility solution can help various industries implement simplified deployment of sensing, connection, and computing convergence, making them ready for the digital transformation. In addition to areas with high digitalization and good power conditions, the digital integrated site power facility solution can also be used in areas without mains or with poor mains to provide universal power supply for local enterprises and residents, meet daily working and life requirements. Till now, we have introduced the two application scenarios of the digital integrated site power facility solution. In the short time of appearing on the market, it is simple, reliable, intelligent design concept has won the industry's general recognition. At this year's Interrupt conference in Tokyo, Japan. The solution won the Best of Show Award grand prize. And till now, the solution has been verified in many industry scenarios, facilitating the digital transformation of those industries. I guess this may be the first time for your listening Huawei talking about so much side power things. But in fact, we have accumulated more than 20 years of technical experience in side power area since 2013. We have become the market leader with #1 market share in this field. In addition to the outdoor cabinet solution, we also provide the indoor power supply solution, pole-side solution for small-sized site, and the NetEco intelligent network management system. This solution forms the iSidePower series of intelligent side power facilities. Huawei iSidePower solution is designed with a simplified, intelligent, and reliable concept. And we always keep an open mind about cooperation. Together with our customers and partners, Huawei is committed to build the most solid digital world energy base and accelerating the digital transformation of the industry. We believe that the digital world of all things sensed, connected, and intelligent is coming soon. Let's work together to be prepared for the changes of coming areas. Thank you.
Thanks, Mr. Yao. Exciting to see what's coming next. So we've come to the end of today's event. Thank you so much for tuning in and finding out what Huawei Digital Power is all about. We are looking forward to seeing you all in person very soon again. But until then, take good care and all the best.